Problem solving. Okay, problem solving in with quadratic equations, essentially mathematical modeling, right? Mathematical modeling in a sense that when you are looking at a word problem, you want to make it into a mathematical question for it to be solved. Something that you guys have been doing all along, right? Now we're doing it with degree 2 or quadratic equations. Yeah? Okay. So, first question that we are dealing with is two planes travel at right angle to each other. So that's the first piece of information that we have. And they leave the airport at the same point at the same time. After 1 hour, so information that we have, we're going to sort of make sense of the information at right angle to each other, right? Leaving at an airport, so same spot, at the same time, right? After 1 hour, the planes are 390 kilometers apart. If one plane travels 210 kilometers per hour faster than the other, what is the speed of the slower plane? So we need to make a mathematical model of this, right, and then solve for it. So we're going to start with the let statement. Let x be the speed of slower plane. Why am I setting x to be the speed of the slower plane? That's what I want to find, and I can add something to it and make it the faster one, right? Okay, and then if x is the speed of the slower plane, what is the speed of the faster plane? X plus 210 is the speed of faster plane, right? So some information is already done for us. We know the relationship between distance, speed, and time. And we had something that could help us. We go, okay, dTs is something that we used to use, right? We go, okay, if I want to find out what the distance is, a covered distance, then I have times speed, right? We go, okay, distance is equal to time times speed. Okay, so the distance, like if, or we can write it the other way around too. We can go, okay, time times speed is equal to the distance, right? Let me write it that way. So we can write it that way. Okay. Time for both of them is given to us as 1 hour, right? So for the slow one, time is 1 hour, right? Multiplied by the speed of it. What is the speed of the slow one? X. So the distance that the slow one travels in 1 hour is x kilometers, right? Then I go to my right angle model of their travel. Like, okay, the slow one leaving the airport at a right angle to the other one travels x kilometers in 1 hour. Now the fast one. Like, okay, the fast one has a 1 hour time to travel what distance? X plus 210. So the distance that this one travels is what? X plus 210, right? I go to my geometric model of it, and we're going to put it on that one. Okay, this is X plus 210. Now I'm looking at a geometric model of this thing. I have my two planes, yeah, with the happy passengers and everything, right? And I have these distances. I have x traveled this way and x plus 210 traveled right angle to it, right? The distance between the two planes is given to me at this 1 hour juncture, right? At the 1 hour juncture, I know that the two planes are 390 kilometers apart from each other. There is a relationship between these three sides because this is a right triangle. What do you call that? Yes, yeah, exactly. The Pythagorean theorem, right? You go, okay, x squared plus x plus 210 squared is equal to 390 squared. So the Pythagorean relationship exists between these three sides of this right triangle. Now, based on what I have, I can solve for x, which is the speed of the slower plane, because I only have one variable here. So I'm going to expand everything. This is x squared plus, I'm going to expand this guy, first term squared plus twice the product of the two, 420x plus 210 squared, which is 44,100, is equal to 390 squared. That is 152,100. I'm going to put everything on one side, right, and solve the quadratic equation that this thing represents. So simplify everything. I have 2x squared plus 420x plus 44,100 minus 152,100. So I put this quantity on the left side and it becomes negative. Simplify everything. 2x squared plus 420x minus 108,000 is equal to 0. Everything is divisible by 2. I'm going to do that just to simplify it. X squared plus 210x minus 54,000 is equal to 0. After this, all I need to do is to apply the quadratic formula to it. And if I do that, then I can find out what x is. I go, okay, x is equal to minus 210 plus or minus square root of 210 squared, which was 44,100, minus 4 times 1 times negative 5,400, or 54,000, sorry, divided by 2 times 1. And if we solve this and get two answers, one of them is a negative answer, right? Okay, reject the negative answer. Why am I rejecting the negative answer? Because speed is not negative, right? And the other one is 150 kilometers per hour, and that would be the speed of the slower plane. And if I were to find out what the speed of the faster plane is, what do I do to it? Add 210 to it, right? Okay. Now question 8 of the same section, 6.5, right? So once you finish this, switch to that. Okay, so a ranch uses 200 meters of fencing to enclose 2 adjacent rectangular corrals. We want to find the dimensions that enclose a total area of 1,400 square meters. So, 2 adjacent rectangular corrals. We have a rectangular corral here, and we have another rectangular corral here. The dimensions are x and y, right? Okay, these two are adjacent to each other, as in like they attach to each other. So this side is shared between them, and it is the same as x. So I'm going to set that to be equal to x as well. If these two are x, what is the length of this side? Also x. Now, that's y, right? This side is also y. But two variables is not very good. We need to make it into one variable. One piece of information is giving us some way out of this. This is okay. There's this much fencing. The total length of the fencing is 200 meters. As in, if I start here and I go around this thing, right? And also add this, the total amount of fencing that I'm using is 200 meters. So if I go x plus x plus x plus y plus y, right? So I'm adding all of the lengths, right? That's equal to 200. This gives me a way out of having two variables, right? So I'm going to solve for y to find out what y is in terms of x. I have 3x plus 2y, that's equal to 200. I'm going to subtract 3x from both sides, so 2y becomes 200 minus 3x. I'm going to divide both sides by 2, and y is equal to 200 minus 3x divided by 2. So now I have the length and I have the width of this thing, right? The total area is supposed to be 1400. Area is equal to x times y. That's the mathematical modeling of it. Can you use that mathematical modeling to solve this this problem and find out what x is? Go for it. I'm going to give you guys a few minutes to try that. I'm going to pause this and we come back to it. So, we modeled it in a way that we go, okay, we have these two corrals that are connected to each other. The width of the corrals is x, right? The length of the whole yard or the whole thing attached to each other is y. But two variables is not a good idea to solve for. If it's in one variable, we can deal with it. But if it's two variables, we can't. So we're going to solve y, right? Or solve for y, so we have it all in terms of x, right? So that's what we did. We go, okay, all the lengths added to each other gives us the length of the fencing that the corral owner bought, which would say 200 meters, right? We go, okay. Through that, we solved for y, and we found out that y is equal to 200 minus 3x divided by 2, right? Area that's enclosed by the whole thing, says the total area is given to us as 1,400 square meters. Okay, area of the whole thing is the width of it, which is x, times the length of it, which is y. So x times y is equal to the area. But the area is given to us as 1,400. So we're going to start replacing these things with those numbers. X is something that we want to find, right? Y, we've solved it for x here. We're going to replace it with that, right? 200 minus 3x divided by 2, right? You go, okay, now everything's in terms of x. I can solve for x. I'm going to multiply both sides of this equation by 2 to get rid of this division by 2. Something that we've done with rational equations before, right? If I multiply the other side by 2, I get 2,800. If I multiply this side by 2, cancels this division by 2, right? So this becomes x times 200 minus 3x. Now, I'm going to expand everything. 2800 is equal to 200x minus 3x squared. And I'm going to put everything on one side where the x squared term is positive, just to make my life a little bit easier. So I'm going to put both of these guys on the other side. I'm going to go with this is 3x squared minus 200x plus 2800 is equal to 0. Now I have a quadratic equation that I can solve using quadratic formula. I'm going to go, okay, x is equal to minus 200 plus or minus square root of minus 200 squared minus 4 times a is 3 and c is 2800 divided by 2 times 3. And if we solve this, I'll leave you guys to do the arithmetic for this, because this is like lengthy calculator stuff. Go ahead and do that for yourself, right? One of them is going to be 20, yeah? And the other one is 47 something, or 46 something, 46.7. So you get 2 positive answers, right? For each positive answer that you find for x, you can find a different value for y, right? So you go, okay, x equal to 20 gives me y is equal to, based on what I had here, 200 minus 3 times 20 divided by 2 is equal to what? 70. Y is equal to 70. So one set of dimensions is going to be 20 by 70, and another set of dimensions, when x is equal to 46.7, I get y is equal to 200 minus 3 times 46.7 divided by 2 is equal to what? 30. Right? So I get 2 different sets of dimensions. Is that reasonable? Yes, it is. There's nothing wrong with finding 2 different sets of dimensions for this thing to add up to 200 meters when we divide it up into those dimensions, right? And multiply to make that area 1400. Fair enough? Okay. Now, there's another question, question 12. On the same page, I believe. A circular lawn is surrounded by a flower bed of uniform width. If the flower bed has an area of 36 square meters and radius of the entire garden is 8 meters, we want to find the width of the flower bed. So, we have this radius, right? So go ahead and do the drawing in your workbook. You have this radius 8, right? This is the width that we want to find. This is a uniform width around this circular thing, right? That means that there is a circle on the inside, right? There's a circle on the inside. That circle on the inside, the radius of it, we don't know. That's radius r. The width of this flower bed that happens to have all the yellow flowers in it, apparently, very apparently, right? Yeah. You go, okay, this width is equal to the longer radius, which is 8, minus the shorter radius, which is r. So that's what we want to find. We want to find w, right? But to find w, we have another problem. We need to know what r is, the radius of the smaller circle. One clue is given to us that the area of this sort of flower bed surrounding this thing is 36 square meters. Yeah? How do we find out this area? Or how did they find out this area?
The area of the entire garden minus the area.
Good. the area of the entire garden minus the area of this circular bit on the inside, right? We go, okay, so we go area of flower bed which is 64, or no, 36, sorry, 36 is equal to pi times h squared, which is the area of the larger circle, right, minus pi times r squared, which is the area of the smaller circle, right? That would be the area of the flower bed, right? Okay, so now in this formula that we have here, in this equation that we have here, we have everything except for r, right? So we solve for r. Solve for r. How do we solve for r here? Well, we can put this guy, or let's put everything on the left side, right? So we get pi r squared minus pi h squared is equal to, put that guy on the other side, negative 36. I'm going to move the pi h squared to the other side, makes it positive. So pi r squared is equal to pi h squared minus 36. Then I'm going to divide both sides by pi, so r squared is equal to everything divided by pi, so pi h squared minus 36 divided by pi. But I don't care about r squared, I care about r, right? So I'm going to take a square root of both sides, so r is equal to square root of pi h squared minus 36 over pi, plus and minus. Do I care about the minus? No, why don't I care about the minus? Because this is a length, right? Length cannot be negative, at least not in the three-dimensional world, right? What? No, you know, if you lived in a six-dimensional world, who knows, maybe. But not now, right? So we go, okay, r is equal to this. This can be calculated. We can punch this into the calculator. And if you punch it into the calculator, we can approximate it. This is about 7.25. Yeah? So r is equal to 7.25. But we want to know what w is. W is 8 minus 7.25, which is equal to 0.75 meters. That's the width of the yellow flower bed. Yeah? Good. Okay. Now I want you guys to flip back to 5.6 and go to question 8. 5.6. And I want you guys have about 10 minutes. I'd like you guys to work on that yourself, right? This is a 5.6 functions, right? You have all the information for the mathematical modeling of this question and all the information about functions and quadratic equations and maximizing things. So go ahead and work on this. I'd like you guys to work quietly. I'd like Tiger to sit in his seat, yeah, okay, and Kevin to put that plane away and start working on this one on his own, right? You start working on this one. Let's see if we can get this done. Or let's see if you can put a dent into it. Some of you guys already worked on it because I told you to work on it, right? If you haven't, go for it, right? And then I'm going to post the answer for that on Ning, and then you can check that out later, right? But go ahead and work on that. I'm going to pause this. I'm going to put the H work up as well, right? So make a note of the H work and start working on question 8 and 5.6. Okay, so a 20 centimeter wide sheet of metal is bent into a rectangular trough. We want to know how high must the trough be to maximize the trough's volume. First of all, the trough's volume is maximized when the cross section is maximized. So if the cross section is at its maximum area, we have the maximum volume for the trough. So let x be the length that we fold the sheet at. So we set x to be the amount that we fold the sheet up at. The other side will also be x. And then the length that we have in between is going to be y. Now we know the length of the sheet is 20 centimeters. So x plus y plus x is equal to 20 centimeters. So now we can solve for y plus 2x is equal to 20. So y is equal to 20 minus 2x. And then this way, we only have one variable to deal with, so we don't have two variables and we don't have a really tough thing to deal with. Okay. Volume is equal to area of base times the length. But we said that area of the base has to be maximized for the volume to be maximized. So area of the base, which is x times y, can be modeled mathematically as x times 20 minus 2x, which was y when we solved for it. So this area is equal to 20x minus 2x squared. Now we need to maximize this. We want to find out what the maximum of this 20x minus 2x squared happens. And when we find out what, at what value of x this becomes maximum, then we can find out how much of the sheet we need to fold out. So to maximize this, we need to see it as a quadratic function. This is a quadratic function, f of x, which is equal to 20x minus 2x squared. This is a quadratic function of the form ax squared plus bx plus c, right? The leading coefficient, which is the negative 2x, I'm going to write it in the descending order, negative 2x squared plus 20x. The leading coefficient is negative, so therefore this is an upside down parabola, or a parabola that opens down. The vertex of this gives us the maximum. So we need to find out what the x coordinate of the vertex is, and if you find out the x coordinate of the vertex, that's basically the x value that maximizes the area. So that's what we're going to do. We need to find out what the coordinates of the vertex is. The coordinates of the vertex we can find it by completing the square. So I'm going to complete the square. I'm going to take a negative 2 as a factor. And I'm going to complete the square in here. So I have negative 2, x squared minus 10x plus something minus something. I'm going to take this negative 10, I'm going to divide it by 2. I get negative 5. I'm going to square negative 5, and I get 25. I'm going to put this 25 here as plus 25 and minus 25. Now the first three terms of this are perfect squares. So I get negative 2, x minus 5 squared minus 25. Once it's completed, then I'm going to expand it and write it in a completed square form. Minus 2, x minus 5 squared plus 50. You go, okay, this is in a completed square form, right? So the coordinates of the vertex are going to be positive 5 and 50. So x equal to 5 gives the maximum for the function f of x. Therefore, x equal to 5 gives maximum for area of the cross section of the trough and therefore x equal to 5 gives the maximum for the volume of the trough. And there's the H work, and I'll see you on Monday.